All right, here we go, here we go, here we go again. Let's get into this practice test. First question. It says BCDE is going to OPQR. So DE is right here. So it's going to be in the same location. So it'll be QR. Second one. Which congruent statement does not match this? So when I'm doing this, you could use the picture to draw on the congruent parts, or what I'm going to do is just look, okay, D and F should be in the same location. So first I'm going to look to see if D and F are in the same location. Yes, 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 yes. Okay, all of those have that, correct? E and G should be in the same location. So I'm looking E and G, yes. E and G, yes. E and G, no. So not necessarily, so it would be B. I'm just going to check. E and G, yes. Next. Two triangles are congruent as suggested. What's the value of D? So, as suggested means look at the picture. So here is angle D. Here is the same part. So it would be 30. So given this congruent statement, angle B, right here, and angle Q, so that means they're the same. If they're in the same spot in your congruent statement, they are the same value. So 3V plus 4 is equal to 8V minus 6. It says find the value, the measure. So first I have to figure out what V is. So subtract 3, I get 5V. Add my 6 over, I get is equal to 10. Divide by 5, 2 is equal to V. So now I actually have to plug it back in. So I'm going to plug into this one. It shouldn't matter which one you plug it into. So this is 6 plus 4. So I'm going to say it's 10 is equal to measure of angle B and angle Q because they are the same. So which angles, triangles, are congruent by angle, side, angle. So the first thing I'm going to look at is which one has an angle and then a side and an angle. So here's an angle, side, angle. This one's angle, side, angle. Here's my angle. I do not have that side because in order to do angle, side, angle, I would need that side. So these are my two statements here. Now I'm going to look at these congruent statements. So T should be in the same spot as G. So I'm first going to look at that. T and G. That one works. T and no. And T and G. So no, those are also not in the same spot. This is the only one that had those in the same spot, so it would be C. It says angle D is congruent to angle A. So I'm going to actually use this picture and draw on it. Angle D and angle A are congruent. Angle C is congruent to angle F. What additional statement does not allow you to conclude that the two triangles are congruent? So first it says BC is congruent to EF. So I'm looking at that. If that were true, then I would have an angle, angle, side. So that means it would allow me because angle, angle, side is a way to prove that two triangles are congruent. B, I would have angle B and angle E. That means I would have all three angles are congruent. We do not have a shortcut for all three angles, so that would not let me. I'm just going to make sure to check the other ones. It says that AC was congruent to DF. That would also work because that would be an angle, side, angle right here. And it would be AB right here to DE right here. But also works. Angle, angle, side if we knew that information. Next. What else must be true to provide that it's side, angle, side? So one thing that I already know looking at this picture is that this has to be congruent to itself. So we already know that. That's already given in the picture. Without actually making a statement, we know it. We need to know side, angle, side. So actually if I look at it, it's just one triangle, side, and then here's my angle, and then side. I would need to know this side, in order to do side, angle, side, is congruent to, again, here's my side that I have, here's the angle, and here's the other side. So I would need to know that these two sides were congruent to use side, angle, side. So AD congruent to BC. So that is the only information that I could use. So from the diagram, can you prove that these two are congruent and why? So looking at this diagram, I cannot use angle, 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 even though in this picture we do have that. But we do not have a shortcut. Angle, angle, angle. I do see that this is going to be congruent to itself. And since that is congruent to itself, it looks like I could use angle, side, angle. So I can prove this by angle, side, angle. Another way that I could prove it would be angle, angle, side. Or angle, angle, side. Any of those. But angle, angle, side, if you look, is not an option. But the only option that would prove it would be side, angle, side, angle. Again, because this is what we have. Angle, side, angle. So my first one for proof, number 9. One thing about this proof, if you do not have this, it will be marked wrong. Even if it's the given, if you do not have these symbols up here, oopsie, I would get marked wrong. That should have a DE. So my second statement, one thing, again, that you should have been thinking about is if parallel lines are given, I should be looking for, with my two parallel lines right here, I should be looking for that Z. Now this one is actually a special case, because I'm going to write two different options you could have for this problem. I'm actually going to write down all the information that you could use, and then I will go into the different ways that you could have used it. So because of those two lines here, with my parallel line, so I can say this angle right here, using my parallel lines, and this angle right here, so it'd be angle A, B, C is congruent to angle D, E, C by alternate interior angles. However, there's another one that when I'm looking at this problem, using those same two lines, because I'm still using my two parallel lines, here's the line that can help find the Z. So this angle and this angle. So I could also say for the same reasons, I'm going to just have the same reason, angle B, A, C, and it's very important that you write this correctly, and angle E, D, C are also because of alternate interior. Now the other thing that you could say in this picture, when I'm looking at this, is I also have a pair of vertical angles. So I could also say you need to make sure that you use 3 letters for this. BCA is congruent to angle DCE because of vertical. Now here's where you could do either all 3 of these or just 2 of these. And now I can say the 2 triangles are congruent. So triangle, again, this is your proof statement, so you should not screw up the order of these letters, is congruent to triangle DEC. Now, the reason why I have a lot of options here, because this was given, I could use angle, side, angle. If you named these 2 angles, you didn't have to name the purple one, but you could say angle, side, angle. You could name the purple green one, and you could have done angle, angle, side. Or you could have named the purple blue one and done angle, angle, side. So those are the two options that you have there. You could have done angle, angle, side, or angle, side, angle. Again, either one of those would work for my proof because I made all those 3 statements of the angles right there. Next proof. So I have my given here. So now when I'm looking at my picture, first thing I notice is that I have this overlapping side right here. So I'm going to say my second statement is going to be AC is congruent to AC. The reason why is because reflexive. So I'm going to make sure you draw it on your picture then. And the next thing I'm going to do, it says that bisects BAD. So I'm going to highlight this first. It bisects this line bisects this angle. That means you have to know what bisect means. Bisect means cut in half. That means this angle will be congruent to this angle. So that's going to be my next statement. Angle BAC is congruent to angle CAD because definition of bisect. And now I actually have 3 parts there, so I'm going to just draw one triangle all by itself. So this is what actually we have here. Now I can say triangle ABC is congruent to triangle ADC. And the reason why, if I look, I have a side, and then I have my angle, and then I have a side. So it'd be angle. No, it'd be side, angle, side. So next one, kind of like the one I just did, because I notice again in this picture that I have an overlapping side. So I can say M, that's my M. O is congruent to M. O. And the reason, because of reflexive, when something is congruent to itself. Again, I have bisects. I have it bisects this angle, PMN. So PMN. So it bisects this angle right here, cuts that in half. That means this angle is congruent to this angle. So my next step will be NMO, congruent to angle OMP. The reason why, definition of bisect. So now again, if I look at just one of my triangles, I have this, I forgot to draw this on there, and this was also in my given. So that and that. So now I can say the 2 triangles are congruent. Triangle PMO is congruent to triangle NMO. And the reason why is angle, side. So I have BC is congruent to AC, that's my given. It says D is the midpoint of BC. So here's BC, saying this is the midpoint. You have to know what midpoint means. Midpoint means in the middle. So if that's in the middle, you know that these two have to be the same length. So I'm going to say side BD is congruent to side DC. The reason why, definition of midpoint. I also noticed that these two sides, or this is going to be congruent to itself. So AD is congruent to AD. Again, reflexive. Now I have 3 parts. So I can say triangle BAD is congruent to triangle CAD. And again, if I look at those 3 parts, side, side, side. So then next one, which one would I use? Now, if for some reason you can't remember these shortcuts to prove congruent triangles, sometimes you might want to look through the test. Maybe there'll be a question like this where you can see some of the shortcuts. So back to the problem. What would you use, which one to prove this? Well, one thing, this would have to be proved by CPCTC. So it would have to prove the 2 triangles are congruent first. By looking at this picture, I see that this would be congruent to itself. So when I look at this, I would have a side, angle, side. So I could prove the 2 triangles are congruent, and then I could prove the 2 angles are congruent by CPCTC. So it'd be side, angle, side. Same type of thing here. I would have to prove this by CPCTC, so I'd have to look at the triangles first. These are not, repeat, these are not parallel. These are not parallel, so you could not look at this Z. That'd be incorrect. But I do see that I have vertical angles right here. So now I have an angle, and then I have a side, and then I have an angle. And I should have actually done this, so that's a different image than these 2 given angles. So it'd be angle, side, angle. Another proof. So I have CB congruent to CD, and angle AC or BCA. So this angle is congruent to DCA. So this angle. Now, one thing when I'm looking at my proof, I'm trying to prove not triangles, but something else. So I'm going to have to first prove triangles, and then I can look at the congruent parts of congruent triangles to see if they're congruent. Otherwise, people know them as CPCTC. If I see that AC would be congruent to itself, right there, so I'm going to write that in there, and that would be reflexive. So now I know that the 2 triangles are congruent. because I have triangle, I'm going to just say ABC first. Congruent to triangle. I went in the order A, B, C. So I have to make sure that I highlight nothing, the one tick mark, and then my angle. So I have nothing, and then the one tick mark, and then my angle. So it had to be the same as A, D, C. And the reason why, again, if you look, we have an angle, and then we have we have a side, and then we have an angle, and then we have a side. So that'd be side, angle, side. And then we can say BA is congruent to DA. Ba is congruent to da. CPCTC. You can always check your congruent statement. BA should be in the same spot as DA, which it is. Good job. Next. What's the value of x? So when I'm looking at this picture, first thing I see is that these two are congruent. So that means these two, because there's the opposite, are congruent. So this would also be 56. So I have 56 plus 56, which would be 112 plus x. All the angles and only angles equal 180. Side lengths do not equal 180. So I subtract the 112, and I get, this is 8, 7 minus 1, 68a. Next. I've said this to a couple of people for this next problem. This is a very bad problem because it wasn't written correctly. First thing you notice though, it said all these are congruent. If all the sides are congruent, all the angles and only angles would be 60. I'm looking for angle A, B, C. I'm looking for this whole thing. So now I have to find this little guy. And I also noticed about this one is that these two are congruent. So this angle, because these are my opposite sides, and this angle would be congruent. So this and this are the same. So I have 2x, because both of those I could label x plus 110 is equal to 180. So subtract my 110, and I get 70. X would be equal to 35. So this angle right here is 35. But again, I'm looking for this whole angle, not just part of it. So 35 plus 60 would give me 95. Next. The wall in front of an entrance to the Rock and Roll Hall of Fame, that's a lot of information I probably don't know, is an isosceles triangle. That's all I really need to know there. Isosceles triangle. So I'm going to just do that. Isosceles means two sides are congruent. The triangle has a vertex angle of 102. What are the base angles? Base angles are the angles that are congruent to each other. So these two are congruent. That means this is 102. So if these two are congruent, I can just put x and x. So 2x, because again, x plus 102 would be equal to 180. All the angles are equal to 180. So if I subtract that, that'd be 78. And then divide by 2, 35 plus 3 is 38. So it'd be 38. And by 38, I actually mean 39. 39 would be my base angles. Next one. First thing you notice here is that this is isosceles. So this angle would also have to be x plus 5. Because these two are my congruent sides. So across, those would be my two congruent angles. So I'm looking for the value of x. Again, all the angles in a triangle, that's not sides, is equal to 180. So I have this. These two are all like terms. Negative 10 plus 5 plus 5, that would give me 0. So these actually all cancel out. And then I have, these are all the same. So I have 3x is equal to 180. Divide by 3, x would be equal to 60. So technically, that is an equilateral triangle since all the angles... Nope, I'm wrong. It's not equilateral because I would have to plug x back in. But I don't have to in this case because I'm just looking for x. But this angle would be 60 minus 10. So this would be 50. This would be 60 plus 5. So it would be 65 and 65. I was kidding. Last one on this page. What additional information do you need for HL? So when you're doing HL, first you need to have a right angle. So that one's already there. H is the hypotenuse. So you need to know the hypotenuse are congruent. And so far I do not know they are congruent. So I would need to know AC is congruent to DF. So AC, DF, that last one. And the L stands for a leg. But again, we already got that. Next. So hypotenuse leg theorem. So when I'm looking at this, which triangles are congruent by hypotenuse leg? So first thing I'm looking at in all these, they all have right angles. So at least we have that taken care of. Next, you want to see if the hypotenuses are congruent. So those two are. So 2 tick marks, 2 tick marks. Here, a no and a no, because it has to have a hypotenuse. So this is the hypotenuse of one, and this is the hypotenuse of the other. So no, those are not congruent. And here, those share the same hypotenuse, so yes, hypotenuse are congruent there. And then make sure you have a leg. So this one's already out because of the hypotenuse. And now I'm looking at my legs. Got 2 legs, I got 2 legs. I got 2 legs, hold me down. So 1 and 3. 1 and 3 would be B. Oh, look at this, another proof. Awesome! So one thing, and I did talk about this in class, this is what was given. It's already on the picture, but you have to make this statement. If you don't make this statement, then your proof is not going to be correct. So first thing I'm going to do is make that statement that's already on my picture. So I have to name those angles correctly. So angle SDH and angle SDT are right angles, and that would be definition of perpendicular. So that's already on my picture. The other thing that was stated but isn't on my picture yet, this was in the given. So it looks like I have a right angle and the hypotenuses are congruent, so that should give me some sort of hint of something. And then it looks like SD is congruent to SD. SD, South Dakota, is congruent to itself. That's going to be reflexive. So if I would look at this, I would have a side angle, or angle side. I'm not going to write that out, but we do not have an angle side. That's not one. However, we still do have 3 parts, so we can still say that these 2 triangles are congruent. And the reason why they are congruent is because the 3 parts we have help prove hypotenuse leg. And if you want to, you can write that little r to remember you need the 3 parts. You must state the right angles if you want to use hypotenuse leg. What has the common side? So first I'm going to trace this out. C, D, E. So here's one triangle, C, D, E. And my other triangle, F, E, D, F, E, D. So one thing also, wherever they start and stop. So here, this is where they overlap, start and stop. D, E. Or E, D. It's the same thing. Another thing I could do is just look at my 2 triangles stated here. Because if they share a common side, they have to start and stop in the same spot. And the only 2 points that are both triangles are DE, ED, which are the same line. Next. So what common side? Again, just looking at this without actually tracing out what 2 letters are the same. I have NMP, and then I have OPM. So PM is what the 2 letters that share. So it would be PM or OP. So this one right here, or just by looking at it, this is the side that this triangle and this triangle share. It has to be the whole triangle. Is this my last one? What? I'm having too much fun. I don't want to go and upload this video. That's going to take a long time. So, looking at this picture, this angle overlaps in both of the larger triangles. So if you're not sure which triangles you're looking at, you should look at your proof statement. We're looking at A, B, D, so this larger triangle, and A, E, C. So one thing again when I'm looking at this, if a letter repeats, that's probably where you should focus your eyes to see what is the same. So angle A is going to be congruent to angle A. Reflexive. Just be aware, make sure that if you do not have this, I will mark it wrong. If you do not have this, I will mark it wrong. If you stated an angle and should have had 3 letters instead of 1, I will mark it wrong. So now I can actually go to my proof statement. I can say triangle A, B, D is congruent to triangle AEC. And I would always highly suggest to draw one of your triangles, or both of them, if you want. Your life, you live it. And if I look back, I said AB, so this length right here, congruent to AE, so I don't have A either. Angle C, so I don't have angle C, but I do have angle D. And then my second statement was angle A is congruent to itself. So that will help me know what do I have. Start at someplace that has nothing, and either you can say side, angle, angle. If you start here, you have angle, angle, side. Either way, it's still correct, though. That's it. That's all we have here. So, you, I'm talking to you. You have a great, grand, wonderful time of your life right now. Just live life to the fullest. Hopefully you are preparing yourself for this test that I've been talking about almost for this whole semester long. Have a good one.